Without further delay, I'd like to introduce today's presenter, Michelle Bustamante, Chief Architect for the iDesign Inc. Michelle, you now have the floor.
Thank you, Sarah. Welcome, everybody. So we're here with another Windows Communication Foundation webcast live. This is part 3 of 15. So today I'm going to be talking about service contract and data contract versioning. And this is, again, part 3 of a 15-part series. So the 2 that you've missed has been an overview of WCF, and then, of course, an introduction to data contracts, service contracts, and other such things. So we'll make sure that you go back and take a look at those things if you're new to WCF. Now, a little bit about myself. I'm an architect with iDesign. I do architecture consulting and training and focus a lot on the .NET 3.0 stack these days. I did just finish a book on WCF, so a lot of the things that I'll be sharing with you are based on things that I've spent the last 2.5 years or so working on. And you can actually download all of the code for my book at the website shown on this slide, www.indigogirl.com. And the book code right now that's posted is the C# code. I'm so close to posting VB code, but it's taking a few weeks, obviously, to get that all wrapped up. There's lots of code in there. And then, of course, my other blog, dasblonde.net, is the place that you can go to download other relevant session and things that I do from month to month. So just keep an eye on that. And so without any further delay, let's just get started. So today I'm going to be covering versioning scenarios for WCF services. And with that, we're going to talk a little bit about strict approaches versus non-strict approaches to versioning, because obviously there are some different approaches that one can take in a company based on how agile you need to be, for example. The things that we'll be talking specifically about include data contract versioning and how that impacts downstream entities, for example. And that's kind of important because if you do need to make some sort of adjustment, if you will, to some of your business entities, what does that do to your service contracts? And so we'll discuss that. And then we'll talk about when you should version service contracts formally and the associated endpoints that you make available to the actual public-facing clients. Now, to ensure backward compatibility, there are also some things you can do, so we'll be discussing some of those features as well. The prerequisites are for this session just that you've got, of course, experience building .NET applications, and also that you have a basic understanding of WCF and contracts. So if you're new to WCF, you might find I'm jumping ahead a little bit, but I imagine so far you'll still be able to follow along. And so to get started, I'm going to do a bit of a review just quickly on contracts and policy. So as you're probably familiar, if you've done some work with WCF already or played around with it, all clients and services to communicate with one another have to agree on some form of contract and possibly policy related to security and so forth. And the way this works is when you create a service, what you do is you end up generating a series of, for example, operations that are available at a particular address. So a set of functions, if you will, that can be called. And those get wrapped up into a document called a Web Service Description Language document, or WSDL. And that WSDL contract describes where the service is located, what are the operations available, and of course all the information the client needs to know about sending information to call an operation. So what does the message look like? And then the return from that message, if there is one, what does that look like? So that way clients can generate proxies that look a lot like the service object, and they can work with CLR types if you're working with .NET in order to invoke the service and not have to write all the nasty code that serializes XML. Now, on top of the Web Service Description Language, inside Web Service Description Language, there is also a section for something called policy. And there's a specification for this called WS Policy, which is not quite ratified yet. But OASIS and other standards bodies do have some level of course, advanced standards beyond WSDL, and policy is one of those. And so it's being used today at least to communicate metadata between clients and services. So although it's not ratified, there are many platforms supporting some version of policy. What it really does is it describes things like what is the authentication and what is the authorization requirements, for example, for calling clients. Do I need to pass a certificate or a Windows credential or a username password? Other things like whether or not the service supports transactions, reliable messaging, and these are things I'll be talking about in later webcasts. But the point is that this is part of the contract. It is inserted into the WSDL. So like I said, WSDL describes the service and its endpoints and what the messages look like. And it can optionally include a WS policy section, which can include information about whether or not we require a certain type of security, whether we are doing reliable messaging, and other things that I'll be talking about later, other protocols. So this is really important because in terms of dealing with versioning issues, once you publish that WSDL document, it's final. And so on the one hand, if any clients consume that document, then there is an understanding that you're not going to change those things, because if I'm sending you a username and password and you decide I need to pass a certificate, so let's say you're changing the policy, then that will affect me, right, as a client. I'm expecting to pass a certain type of credential and it's no longer going to work. So in theory, you do need to make sure you don't change the WSDL document or the policy if you want to make sure clients can communicate with you. But a lot of times what you will hear is that policy and WSDL are separate things, and that policy is, in theory, allowed to change. And the reason for that is because there's a thing called metadata exchange that can dynamically query what the policy for a service is. And in theory, if we were writing clients to be forgiving of changes to policy, then what we would do is inspect dynamically what credential do you want, and if I'm able to produce a UI to gather that from the user, then I would do so. So I'm kind of getting into some advanced things here, but really I'm just trying to emphasize the point that today most people don't do that. That dynamicness, if you will, is not used in very many environments, only possibly with federated security, which I'll talk about in a later cast. So what we want to do is be careful that when we publish a WSDL, these are the operations, these are the messages the client expects to send, and also these are the policies. And any changes you have to very carefully control so that you don't break your clients. And so that's the theme of this webcast, is that we want to make sure that we handle in a graceful way changes. And the first thing we want to talk about there is version tolerance. So WCF contracts, which include service contracts, data contracts, message contracts, and so on, they're version tolerant by default. And what that means is that if a client sends extra data, the service model, which is WCF, will ignore the extra XML elements that came across the wire and just throw them away. And so it won't obviously save the data for the user that sent that, but it will by default ignore it and not require that the message is an exact match to whatever the data contract says. It will also forgive missing data if it's not required. So that's an interesting thing. By default, if you just create a basic service contract and a basic data contract, you can do an awful lot of interesting things that modify those contracts that don't affect the client. They may send extra data, they may forget to send some data, and as long as you don't require that information, then essentially you'll just initialize the data with defaults. And this is all handled by the data contract serializer, which is what handles serialization by default for WCF. So messages come in, they get deserialized. Messages go out, they get serialized. So let's start with service contracts and just talk a little bit. This chart actually lists the things you can do to change a service contract and what the effect would be on a client. And what you'll notice here is that I can add new parameters to a service, and that will actually not be a problem. The client will be unaffected. The new parameters will just be initialized to default values. So if you added a parameter and a version 1 client just doesn't send it, you just have to be prepared as a service developer that the default is okay. The other thing you can do is you can actually remove parameters and the client is unaffected because the extra data will just be ignored and lost at the service. Hopefully the client is not sending information it's expecting you to send back. or vice versa if we're talking about services returning data to clients. So we do need to talk about how we preserve unknown data in those cases. The other thing you can do is you can actually do some strange things like modify parameter types and return value types. And that is not necessarily an acceptable practice, but what will happen is an exception only occurs if the types are not compatible. So if I, for example, receive a date time and then I change that parameter to a string, it will actually be received as a string that looks like a date time value. And so it might not give you expected results, but it will potentially work. So you want to be careful about that. You can also, of course, add new operations to a service contract, and what that means is that version 1 clients just won't know about the operation unless they refresh the proxy. Whereas removing operations would cause a big problem because, of course, clients that think there's an operation will be sending messages to something that doesn't exist. So it kind of makes sense, right? I think that you get the idea that I can build a service contract and things will be forgiven potentially if I make changes. But just be careful about those drastic changes. Now with data contracts, it's quite similar. By default, when you create a data contract, you apply the data member attribute, and you'll see an example when I go through a demo. So if you're not familiar with these things, you'll get a chance to see it in the next demo. But essentially the data member attribute by default just creates non-required members. So if you were to remove some of those members, clients will just send extra data that gets ignored. And if you were to add new members, clients will just not send the data that don't know about it, and you will have to deal with initialized defaults. So all this is automatic. What you'll see, again, is that if you modify a data member type, as long as the types are compatible with the information passed in XML, it will work. Otherwise, you'll get an exception at the client. And if we remove required members, well, of course, we expect an exception there, don't we? So what I'm going to do is show a quick demo of how WCF is version tolerant, and then we'll take a look at some other things. So this will just share my desktop in a moment. And what you should see here is a solution. The first thing I'm going to show you is the data contract in the solution. What you should see here is the link item type, which is a data type that holds an ID, a title, a description, a start and end time, and a URL. Now actually, this type has several data members, and I've already provided order, but what you'll notice is that currently I've actually commented out the end date. So there's actually no data member publicly exposed as part of this type just yet for a reason, and we'll talk about that. So right now what we have is a starting date data member, which is required, by the way. You'll also see a URL, which is required. You'll see an ID, which is required. You'll see a title, which is required. And you'll see a description, which is not required. So we've got some required fields, we've got some non-required fields. Now, as far as the client goes, the client has already generated a proxy that looks very much like this. And what you'll see when I open the form here is that when we create a link item at the client, which is using the generated type called a link item on the client side from WSDL, it doesn't know about the end date at the moment. So you'll see this is where I create a new link item and where I set the values to make a call. So we'll just give it a run so that you can see that that works. So I'm going to start the host first. And then I'll go ahead and run the client. The client is just a simple Windows Form application. And this is just going to allow me to send a link item. It's going to describe a CD release party with a particular date, and then I'm going to call save. That'll hit the breakpoint, which will then allow me to initialize the type. So we're just waiting for it to get to the breakpoint. I guess I didn't recompile, so it thinks it's going to a different directory for that. I'm going to actually recompile it. When you move a solution, it does that sometimes. And terminate the host so it can build that. Okay, so now it's ready to go. I'll start the host again, and then start the client again. It's been rebuilt. So the client application, Windows form, same one as we saw before. And when I click Save, which will be in a second, it's going to hit that breakpoint. Okay, so here we are. It's going to create a link item using the proxy-generated copy of the link item type. And that will call eventually save gig, which is going to pass the link item, which will get serialized, but it does not include that extra piece of information, which is the date end. So no exceptions just means it works. Now I'm going to start making some changes. So stop debugging, and I'm going to go edit the link item. So the first thing I'm going to do is I'm going to actually add this date end back. So you can see that I'm highlighting the data member, and I'm going to make it a required field first. Now you can imagine what's going to happen, right? I'm going to recompile this. The client doesn't know about the date end field. Therefore, it's probably going to have a little problem. Oops. I have to stop the host, or else it will not be able to compile that. Okay, so the date end is going to be a required field. The client doesn't know about it, therefore will not be sending that XML element, and therefore we're going to have an exception. And that's because we added something that was required. So I'm going to go start the host again, and that'll now have a newly hosted service that thinks it's getting a link item with a required field called date end. The client is a V1 client. So when I call save, it's going to do the same thing it did before. I'm going to just hit F5 so that it runs through, and we will get an exception at some point here. So there's the host still running. Client's not responding, sending the message, waiting for a response, and at some point the formatter threw an exception trying to deserialize. Element URL is missing. Why? Because it's expecting it's expecting URL, and instead it got it's not expecting URL, it's expecting date end before URL, because if you recall my link item, the date end is at order equals 4, and URL is at order equals 5. Now, if I were to change this and make this order 6, it really doesn't matter. It's just going to end up having a problem later than earlier. So it will process the URL element, and then it will get to this point and say, hey, where's my date end? So you get the idea. I can actually make this non-required, and of course this is not going to be a problem. It just means that the element is going to be empty. So when I put a breakpoint in my Gig Manager service which receives the value, and I throw that in here, so let's go ahead and start debugging the host. Then what's going to happen is it's going to initialize with the default date time. So that's not very useful to my service, but if I'm okay with that, then I've now created a change that is forgiven. So let's go ahead and start the client. Service is already running. And we'll call save. Now it's a non-required field that we added, so it should be okay. What we'll see inside the link item is that date end is 11001, right? So we've got the initialized default, as you can see. And everything else is properly reconstructed. So we just lost data, essentially, or we're missing data. Okay, so some other things that you can do that are kind of weird, but acceptable, is I could change the field type for ID, for example, to a string. And of course, that long value will just come in as a string, and the client actually won't care. I can also remove non-required fields like description, and that would just end up getting omitted. So simply we would ignore the client which sent the description. But of course, if I remove a required field like this, then we're going to have a problem, which is the same result as if I added a required field, right? So bottom line is reasonable changes are allowed. You don't remove things from data types, especially if they're required. You don't add required fields if clients are already using your proxy or your WSDL and are not knowing about those fields unless you want to break them. And so it kind of makes perfect sense. And if we go to the service, in fact, the same kind of thing applies. You know, I can go ahead and add a new date time, for example, timestamp, let's say, for when they sent the link item, and that's going to be ignored if clients don't send it. It's not required. In fact, you cannot make parameters required in the service contract unless you use a single data contract and use required fields. So basically, this is not required. Date, time is not required. And of course, we cannot remove service operations, because if we do that, then what's going to happen is the client's going to end up failing, of course. And I want to show you that error because it's something that you want to be aware of. So I'm going to go ahead and start the host again. And I'm going to run the client, and notice I did comment out that link item contract, or that operation. And so the client thinks that there's a link item operation when I run it, and it's going to try to send a message. And the message, of course, is identified in terms of which operation it's calling by the action parameter, or the action header. And the action header is going to say, I'm calling getGig. And so let's call save, and we'll just see that that works first, right? And then let's call get. And I'll actually get a useful error. There's a lot of very useful errors in terms of WCF debugging I'm finding. And so this one says the message with action getGig can't be processed. It could be because there's a mismatch with the bindings or whatnot. So really what it's saying is the action can't be processed, right? And that's exactly what's happened. This action doesn't exist anymore in the WSDL. We've removed it. So don't remove members. That's probably the moral of that story. I'm going to actually return to the slides for a second. So the moral of that is reasonable changes can be made, and it will not impact your existing clients or services in either direction. So you know what's reasonable. I've given you a table that kind of outlines what's reasonable and what can cause problems, and we'll talk a little bit more about that. Having version tolerance by default is a good thing, especially if you're doing let's say it's not a formal enterprise application that requires control over every change that happens in each release, but you're a little bit more agile and you need to adjust the application in a monthly release mode. It does give you some liberties that if you don't want to track all the changes, you can just add changes, make changes, remove fields you don't care about, and so forth, as long as it doesn't impact the client. So it can be a good thing, but it's not formal, so that's important. Now let's talk about another scenario here, and that is, what if the client sends extra data and you would like to preserve that information at the server because you're storing the data for the client, and when they request it back, you want to make sure you send back to them the additional data they sent as well as the stuff you cared about. So maybe you're only reconstructing the data contract with certain elements you work with, but you just don't want to lose their extra data. the same thing is applicable when a service returns information to a client. So let's say I have a version 1 client that receives information from a service, like a link item, let's say, in this case. And that information, let's say we've added some fields to the link item. And then those fields, of course, need to be, let's say the client's going to update a few of the elements and then send back an update to the server. In the process of doing that, what we don't want is for the client to lose the extra data the server had returned, because the server might need that in order to properly update the database. So this thing called iExtensible Data Object gives us the ability to preserve unknown elements in either direction. And actually, when you generate a proxy, by default the proxy implements this interface, iExtensible Data Object, for exactly the reason I just said, and that is that servers might have new versions of types that get sent even to version 1 clients, and version 1 clients might be responsible for holding that in memory, making changes, and sending it back, and we don't want to lose that data. So what happens is, by default, of course, we know that during deserialization, any extra data is usually lost, but in this case it's placed in a dictionary. And then during serialization, that same dictionary actually knows the XML element to preserve everything as it was. And the way we do it is we implement the iExtensible Data Object interface on the data contract and supply extension data as a member. So this is what it looks like: iExtensible Data Object, extension data, and then of course the actual property which saves and returns the extension data. And the WCF plumbing handles the rest for you. So let's see a demonstration of that. I'm going to actually return back to a different example here. And so in this example, what you're going to see is a link item like I was talking about before. And right now, the link item has, a full set of fields. So, the description, the title, the ID, the URL, and so on. Now, what happens if I, for example, remove the URL? It's required, actually, so that wouldn't be good. Let's remove something else. I'll remove the description. Okay? So the client's going to send all of the data. We are now ignoring the description, right? So I'm going to go ahead and recompile this. And then we'll give it a run. So I'm going to run the host first. And then we'll run the client. And the client will initialize a link item, provide all the data, including the description. Okay, so the description is here, right? We're going to go ahead and save this link item. So I'm hitting that breakpoint again where I'm initializing the link item with all the data, including the description. We call save. And I'm going to go ahead and just put some junk in the description in the form and call get, and I get nothing back, right? So we lost it. Now the chances of you removing fields from your data contracts after you've published is probably slim, unless you don't think clients should care about that field, because you don't care about it anymore. But of course, this is not a desirable effect, is it? The fact that the client, thought that was information they should be sending. So it depends on if you own both sides, how much control you have over making those types of drastic changes, right? In the case where you want to preserve what the client has sent you, what you do is implement the extensible data object like I talked about before. So extensible data object, I'm going to implement that interface on this type. And what that's going to do is create this extension data. And what we're going to do is create a private extension data element. And I'm going to return m_data from the get property accessor, and I'm going to set m_data to whatever the value is passed in. And so this is actually, again, initialized by WCF. So let's go ahead and recompile that type again. Oh, I meant to say extension data object, excuse me. The data type is the extension data object. Okay, so that's all I've done, right? I haven't changed the service contract. I haven't done anything to any other location. I haven't touched the client. So we're going to go ahead and run the service. Okay, so it's just rebuilding again. And actually, I want to make sure I'm running that with debug, so I'm going to start debugging instead. That way we can hit that breakpoint in the service and check out what the extension data object looks like. And I'm going to make sure I have a breakpoint in the service, and I do. So let's go ahead and I will call or start up the client. And client application in this case, still sending the extra description data. So we'll call save. And this time, when we hit the service, so we're going to hit a breakpoint here, the service breakpoint, what you'll see, has an extension data dictionary in here. It's got a single member, and if we open up members, which I'm sort of drilling down into here, then you're going to see description as the name of the member. It's got a namespace. Why? Because the XML that gets serialized when we return this thing has to look correct, right? So it's got to know the name, the namespace, and then of course the value could be any type of object. So it's got the data type of the value and all the information, which is the string. So what you're going to see is I'm going to hit F5, and then I'm going to try and get that value back from the server. It's going to return the same link item that I was storing in the session there on the server, and I got it back. So iExtension data object is something you can implement to preserve previous clients sending extra data. What you need to be careful about, though, is that this could also introduce the potential of a denial of service attack where all this extra XML is now preserved. And you're creating objects in memory on the server to preserve that thing. So I don't really recommend this approach on the server. I think it's extremely useful for proxies. So if you notice, this proxy that was generated automatically implements iExtension data object by default. I will find it here somewhere. Oh yeah, here it is. It's not the proxy, sorry, I meant the type. So here is my iExtensible data object, and this is link item. So that's the client version of it. We want to preserve that at the client because in that way servers can send extra data that doesn't get lost. We don't necessarily want to do it at the server indiscriminately because of the potential for security issues and other types of denial of service, for example. Now, I already talked about the fact that clients implement it by default. Services can implement it, and I've talked about the risks. You can actually, to protect yourself at the server, you can configure the data contract serializer to ignore extension data objects. And then that way, if other elements, if you don't have control over all the data contracts and some of them happen to implement this interface, then you can actually tell them to ignore that data extension object and you don't preserve the XML. And therefore, the extra XML will just be lost at the server. You can also do this declaratively on the service and code it as part of the service implementation. So the service behavior attribute gets applied to a service and you ignore the extension data object. There's a couple of questions in the queue, so I think I'll just take a quick look at that. Somebody asking, did I get the question from the last session, service versioning, how to for an added method? I'm going to go into service versioning shortly, so maybe stay tuned for that. A graphical representation of what's going on, like a flow schema. I'm about to go through, I have a couple of diagrams we're going to go through shortly, so stay tuned for that. Okay, not sure that one was clear. How does changing the order of an existing data member impact clients? It depends on if you require order. By default, it's actually alphabetical order, and so the data contract will actually serialize in alphabetical order, and if you add new members, then they'll just end up being in alphabetical order. If you require a specific order, then the actual XML that's received and deserialized will expect certain members to appear in that order. Now, I usually recommend that you, right from the beginning, set up the order that you expect, because you want to have an orderly looking schema to share with partners, and it's just better across the board to be consistent. Either require order for everything or don't. Very rarely would you not care about that. So as long as you're requiring order, then you're simply adding to the end, right? Now, if you restructure the entire data contract because you need to insert a chunk of elements, because it's basically a new schema, then there's something else we need to do, and that is version the data contract, which I'm going to talk about. So that was one of the questions here. Can I remove non-required fields from the middle of the data member order? Absolutely. If it's non-required, then the missing element will just be ignored. And if extra elements are sent, they will also be ignored. And then is there any guidelines for member names? So that's really kind of open. Somebody's asking if date start, date end is better than start date, end date. I think that's really a preference that you want to come up with based on the data that you're storing and what's good for you. You just want to be consistent. Can you elaborate on why a denial of service attack is a concern? Well, I think I did, but denial of service attack, basically, where somebody floods the server with requests that are very large. If they know they can get away with that and basically try to bring down your server, what's going to happen? You're going to run out of memory. You're going to have a number of requests. So you need to do a lot of layers of protection. You should throttle the number of requests that can be concurrently processed. You should throttle the size of messages that are allowed. And of course, you don't necessarily want to use memory to reconstitute this dictionary of 100 extra elements for all the concurrent requests, because that's going to put pressure on the garbage collector. And so I think that's related to the security issues of extension object, because it's potentially a denial of service as well. And also because, anytime that you're opening a hole where somebody can flood the server with large messages, then that's a problem. And what's the purpose of service metadata get HTTP get enabled? The question is really unrelated to this topic, but it just means that you're allowed to browse to the metadata and look at the WSDL contract. I'll show you that in a later demo. So I'll address other questions in a bit, but I just wanted to get some of those out of the way. So we've talked about version tolerance and what you can get away with. We've talked about how you can preserve unknown data and some of the risks on the server for that. Now let's talk about some real versioning strategies. So there's a couple of approaches that you might want to consider. One is absolutely strict versioning, which means any change to any data contract or any service contract that will impact the WSDL requires that you formally version, and I will talk about what formal versioning looks like. And then there's a practical approach. Obviously, there's a lot of folks that need to have agile environments. You are definitely locking yourself in if you're going to do formal versioning to where there's some extra development overhead when you make a change. And if you are in a changing environment potentially, then you might consider some practical approaches that are a little less strict. At some point, you will need to do formal versioning for something significant, but maybe there's some things you can get away with beforehand. So version tolerance, for example, provides us with backward and forward compatibility. We can leverage that capability of WCF and take advantage of it, essentially. You can try to preserve unknown elements, but be careful with iExtensible data object on the server. You can forgive missing elements if you don't need them. So if you make changes that maybe you add some new fields that aren't required, then just ignore the missing fields, right? If you can get away with that, that's something you can do without versioning. And then formal versioning would be only for significant changes. So it's a graduated approach in that case. So how do we work with this? Well, let's just consider, what do we do first, right? Version 1.0. I'm going to define some data contracts, which means I'm providing an explicit name and namespace like I talked about in the last webcast. I'm going to set data members and provide them with a name and whether or not it's required or not to be explicit so that it's clear to developers, for example, if we need to make a change. And then also I'm going to provide an order to be explicit so that it's clear to developers if we need to make a change. So the data contracts are concrete, and then anything we do for version 2 or beyond, we just need to decide how strict is it, right? Now in terms of defining service contracts, I'm going to provide, again, an explicit name and namespace for the contract. And last webcast on Monday, I talked about conventions for naming, which you'll see again when I go through the versioning samples. I'm saying that you're going to use data contracts for parameters and return values that are your complex types, right? So any changes to those data contracts presumably impact the service contract as well. So we're building our data contracts, we're building our service contracts, and then that's going to produce a WSDL document, and then of course some policy data, which is really more related to security and other things that we're not discussing right this minute. So how does that look then? Here is a flow diagram that will give you an idea. If you follow the red dot, the version 1 service contract, just talking about service contracts, if we want to be non-strict, then I'm going to look at the following. Did an operation change? Yes. How did it change? Did we add a parameter? Yes. Okay, so version 1 clients won't be passing that parameter, then we can just treat it as optional, right? We will initialize it to defaults and treat it as optional, and we will keep the original version 1 endpoint, no versioning required. Did a parameter change, like a data type? If that happened, that's a bit more significant in my view, and that requires a new version of the service contract and a new version endpoint. I don't think it's reasonable to make data type changes. If we deleted a parameter, if you can handle the fact that you're getting extra data, if you no longer require it, version 1 clients will send extra data, you can keep the original endpoint, no versioning required. If we added an operation, no problem. Keep the same endpoint. It'll just be that version 1 clients don't know about that change unless they refresh their proxy. Version 2 clients will get the new feature, right? And then if we delete an operation, well, that's really bad. So that's another one where I'm highlighting in yellow here. We go to a new endpoint. We have to version the service. When I say no inheritance, what I mean by that is it's going to have to be a formal versioning. Now, if I want to be semi-strict, the thing that changes here is that if I add a new operation, I might want to create a new service contract for new clients that know about the update, and use inheritance so that I still preserve the original endpoint. And I'm going to actually show you how that works in a demonstration shortly. If I want to be very strict, every single change, all roads lead to a new version, okay? Which means no holds barred. I absolutely must create a new service contract, and that's that. Now let's take a look at some visuals before I do a demo on how this approach looks visually. So what we've got here is, if you consider, I'm actually just going to make sure we get all the graphics here, I guess. I'm not sure what's going on, but my slide is missing a graphic that I'm seeing here. Okay, here it is. Good, good. Okay, so what we're looking at here is the service contract Service A is implemented on the Service A type. So Service A is my actual service type. I'm exposing that over endpoint 1 right over here. It's got 2 operations. The clients that generate a proxy from that know about the endpoint, know about the 2 operations, and this is a version 1 client, right? So just consider this as a starting point for the discussion. Now, what's going to happen is when we get a change, or let's say we add a new operation, then what I could do is just add that third operation right here to the existing contract, no versioning, if I want to be non-strict. And client 1 will be completely oblivious to this third operation, but client 2, when it generates the proxy, will get the third operation, therefore be able to make calls and do work against it. Make sense? So that's one approach that can be non-strict, right? And so if we want to be semi-strict, we take a different approach. What we do is we create a new contract, version 2 of Service A. We implement that new contract on the same service type, but we inherit the original contract. And then that way, what I've done is I've got a new namespace here for my new operation 3, just so that internally we've got some versioning. We know what month and what year we introduced these features. But we haven't broken the old client, so we can still go to the original endpoint. So basically what we're ending up with is the same original endpoint, and we've got a new operation available that the original client just doesn't know about. Now, I've got a slide here that you can, when you print, you'll see the example of how we implement this, but I'm going to go through a demo. So this is the Service A with operation 1 and 2, inherited to iService A2, which has operation 3. Notice the new namespace, 2007-07, 2007-06. I have versioned the namespace by month and year. So let's see a demo. I'm going to go ahead and load up a different example here. And what you'll see here is I've got iService A, and it's implemented on Service A, 2 operations. And I've got a client, version 1 client, and it only knows about those 2 operations. So if we actually take a look at the form, you'll see it's got operation 1 and 2, and that's it. Now what I'm going to do is I'm going to create, through inheritance, because clearly if I want to add operation 3 here, it's not going to affect an existing client, right? So what we want to see is how would I do versioning. So what I'm going to do is create another copy of the service contract. I'm going to version it for 2007-07. This would break existing clients if I change the namespace on the first Service A contract. So I'm going to call this iService A2. And I'm going to inherit iService A. So basically I'm inheriting these operations with the original namespace, by the way, and I'm creating a new operation with a new namespace. So that just changes how the message gets serialized with a different namespace so that we can track new versus old. Now what I'm going to do is implement iService A2 on the contract, and I'm going to add operation 3, which we know exists on the new inherited contract. So this is iService A2 operation 3. So what I've done is I've added an operation so that I can respect the fact that I added a new interface and element. Now let's go to the host. The host for this service has a currently single endpoint, Service A. And what I'm going to do is change it to iService A2. I'm not going to change anything else. And this is going to work because iService A2 inherits iService A, so the original client is still going to have no problem contacting the service. So I'm going to go ahead and run that. And if I were to, of course, tell new clients about the service and they create a proxy after I've made this change, then they're going to get all the operations, right? And they'll have access to all that. Okay, so operation 1 still works. Operation 2 still works. Same endpoint, no change, right? So that's one approach to versioning, which is inheritance. I'm going to actually go back and talk some more to the slides here. Okay, so another approach could be that we want to have a semi-strict approach, and this is actually what I just showed you, right? So where we do inheritance, but it's an extension of that where we actually create a new endpoint as well. Why? Because I might want to send new clients to a new address so I can track how many are moved over from the old endpoint to the new one. So I'm actually just then adding another endpoint to the configuration. But I'm still, doing the same thing. I'm inheriting the original contract. I'm just exposing a new contract at a new address. And then that way the old clients still go to the old endpoint. And so they're truly unaffected. They don't know anything about the new contract. And if they add or refresh their proxy, they're still going to get the same one because we're only exposing the base iService A contract. Now, if you want to be formal with your versioning, then what we would do instead is we'd actually create a full-blown new service contract. And with that full-blown new service contract, a new namespace, and we would repeat all operations, even if they're the same. Doesn't matter. Because what we want is to have a completely separate WSDL document, and WSDL is associated with a service. So not an endpoint, but a whole service. So that way we could give a new WSDL to version 2 people, and an old WSDL would be continue to be preserved for version 1 people, which this should say version 1 over here. Sorry about that. What we do is also share some sort of base type that is the actual implementation of operation 1 and 2, because we certainly don't want to duplicate code either, unless there's actually a change to the functionality. So without inheritance, how that looks is I would have the original contract with the original namespace and 2 operations, and then I say, look, we're going to add some new operations, but we're going to completely, strictly make all the clients go to this new service WSDL, and let's repeat the contract in its entirety with a new namespace so that we know all calls coming to operation 1 in this case are coming to the new endpoint, so that we know when we've retired the old endpoint, for example. And so that's helpful for versioning. I have an example that actually illustrates both of these in their entirety, with and without inheritance, so you can take a look at that as part of the book code that I told you to download. Now, taking a look at data contracts, because this is another aspect. So I've so far really focused on, hey, the service contract contains a list of operations, and if those operations change in any way significantly, we do want formal versioning, and then we're going to have a new service contract with a new set of, or a copy of the operations in their new form. And then that way we've separated the endpoints between clients from version 1 and clients from version 2, and then you're free to really make all the semantic changes that you need to, if you like, as well, because you're essentially sending people to a brand new contract. When we talk about data contracts, those of course impact service contracts, right? If I make a change to a data type that's used in a service contract, I'm affecting that service contract, so be aware of that. When we talk about versioning data contracts, we think about if we changed a member or not. And the question is, did I change a child member or not? If not, then what I've done is I've maybe changed a data type or changed, a nested type, and any of those types of changes really mean I'm changing significantly the type, right? We don't go around changing data types and so forth. So if we're making that type of change, we really need to version the data contract and version the service contract and provide a new endpoint to keep it clean. Now, if all we did is add a member, great. Just make it an optional member. Keep the same endpoint, no effect to the service contract, everybody's happy. If we deleted a member, well, it depends if you care about it or not, or if it's going to impact clients if you don't preserve it. So you've got to decide, do I ignore the data or preserve the data? And I can keep the same endpoint. And this is all, of course, in non-strict approach. If we're going to be strict, guess what we do? We have to, for any change, whether it's a change to the data type, a new member, a removal of a member, a change in the way we handle the data, we absolutely go to a new service endpoint, which means new data contract, new service contract, new endpoint. Now the interesting thing about data contract versioning, though, is that we have to deal with the type itself, if it changes significantly, then what do we do with old clients that go to the old endpoint? So I want to talk a bit about that. So for non-strict, our approach should be never remove required members, only add non-required members, and you don't change the namespace. If we formally version the data contract, then what we're going to need to do is something a bit more interesting, okay? We're going to have to update the business objects. Obviously, data contracts are usually something we're flowing around down from the service to the business tier to the service tier. And we're going to need to version the contract namespace, then version the service contract. And then for the earlier clients, we need to probably create a copy of the original object that they used to use and create a data contract for that that represents the old namespace, and then keep that as part of the old service contract. So basically what happens is the old service contract that we're versioning, we need that one to work with or deserialize the messages into another type that's not the primary business entity type anymore. Because the primary business entity type will always be the latest and greatest that we flow down through the channel, which means my old endpoints need to probably do a mapping from version 1 to version 2 before calling down to the business tier. Here's how that looks, okay? So basically what we've got is business objects, data that are being used by the business and data tier. We've got a service contract that uses that data contract associated with the business contract. And we've exposed an endpoint for that. So clients that generate a proxy get the original data contract, right? And so in support of the changes, okay, what we're going to see is something like this. We've got the same business object, but we've added some features or changed the way the data type looks. So we've got to version the data contract, so we just make a change right there on the type, and we call it a new namespace. And we use that new namespace, and we version the service contract, make a new service contract with a new namespace. And new clients go there, and they're all happy. Everything's good. Now, there's a dividing line between these guys, right? So on the other side of things, we create a copy of the business object before we make the change, and we give it a different name, the type. And then we use the original data contract on that type, and we use that type in the original service. So we're actually modifying the original service contract to use a different type, but it's really the original type, if you will. And that way, the old clients can still work. Now the trick to this is that we need to do a mapping for the original clients. If we want to still share the same business code, then it's really important that when messages come in through version 1 clients, they'll deserialize automatically to the version 1 data contract, which actually goes to a business object that's a copy of the original. And we're going to need to map that to the real business object, which is the latest and greatest, maybe setting some defaults, and then call down to the business area through some common code, that's implemented by the new service. So the old service is actually retired eventually, hopefully, but while we're migrating, we're giving people a way to still have their messages respected at the original endpoint and map to the original data contract automatically by the runtime. So I'm just going to give you a quick visual on the data contract versioning, and then we'll wrap up. So there's a different example I wanted to show here. I think it's this one. Okay, so imagine then my link item type. I'm going to make a significant change. And my original service contract, okay, uses that link item. So what I'm going to end up doing is I'm going to version this data contract. I'm going to call it 2007-08. Let's say we make the change next month, okay? Now, in order for this, before I make the changes, in order for this to work, what I should do is make a copy of the type, which I just did. And so the original type is this, right? 2007-07 is the namespace. And I'm actually going to call this link item V1 now. I've changed this data type because this is going to have to be used by the old clients. And it's going to deserialize to the same object we were originally working with, but with the original namespace we were working with. Okay? So that's now become my copy of the original link item. This is my new link item. New namespace, same type. Why? Because my business objects aren't going to change the type they work with. They're still working with a link item all the way downstream to the data. So I can add all the stuff I want in here, make changes, make additions, that kind of thing, and it's not going to affect my old clients because my old clients are going to deserialize to this guy, the original. My service contract then needs to be versioned. So here's what we're going to do. We make a copy of the service contract. And so my original service contract here is going to stay intact. Okay? And my new service contract is going to be 2007-08 or whatever we decide. And we're going to call that iGig Manager Service 2. And it's going to have a copy of the same operations using the core business type. So this is my new service contract using the first class link item type, which means my old link item type is what we need to use for backward compatibility to the original clients. Notice what I'm doing here though. The data contract for link item V1 is the same as the original one we put in this contract. So I've essentially still got the original service contract here, which means there's going to be no effect on my existing clients. Okay? New clients will get a new endpoint with this new service contract with what looks to be the original link item type, but it's really the new one because we added a bunch of stuff and we versioned it. The namespace has changed. Okay, so that's the idea around data contract versioning. It's a little bit of effort, as you can see. You do need to put some thought and planning into this process, but it's fairly mechanical if you think about what I just went through. You just have to kind of get a list of these are the steps we go through and find out, how you want to organize your assemblies, for example. Like, where do we put the old data contracts and the old service contracts so we don't get confused? Like, this is the latest and greatest, and these are the originals, and so forth. So just come up with a convention for that, and then you've got your strict and formal versioning approach. So with that, let's just kind of sum it up here. WCF is version tolerant by default. So you can forget about all this extra effort if you like, if you're comfortable with just, not really being able to track the changes, right, as they happen. Just be very agile, add and change things that are acceptable, like don't remove required items, right? Non-strict then doesn't require much effort on your part, and only when you get to a point where there's significant change, we do the strict versioning approach if you're comfortable with that. You do have to think through the namespace thing, but I've just shown you a couple of quick mechanical ways to change a service contract and a data contract with a new namespace. And the data contract example is probably the most complicated, but you've got some diagrams you can go back to that will help you out, I think, with that planning. So consider your policies ahead of time, and then that will give you what you need. And with that, just a reminder, download all the code from my book at thatindigogirl.com. It's got all these examples for service contracts and data contracts as well as many, many others. Other blog for other information, and iDesign resources can be found here. Some advanced WCF stuff is there. Of course, if you need extra information, have I got a book for you? So my Learning WCF book is now published, but like I said, all the code is available on my website. And I guess stay tuned this Friday for our next webcast. Will be on exceptions and faults. I'm going to take a look at question and answers now while Sarah takes over. And thanks again for attending the webcast today.
All right, thanks, Michelle. And we have a couple minutes to go over some questions. We're a little bit over. So I'm going to go ahead and put up this survey. If you guys have any questions and answers, go ahead and type those in now. And Michelle will take a minute or two answering them verbally, and then the rest she can just enter in via text. And let me go ahead and put that survey up there for you now. So take a couple minutes to fill out the survey. Your feedback and comments are greatly appreciated. And just simply click on the links provided in your interface. and fill that out. And Michelle, I'll hand it back to you. You can spend a couple minutes answering some questions, and then the rest, because we've gone a little bit over, we'll just have to do via text message.
Okay, one of the questions here is, can you give some ideas how to map the old business object to the new without changing the code for the old business object? So you wouldn't change the code for the old business object. What you would be doing is changing the code inside the service implementation. So version 1 clients still go to the original service as far as they know, and then the service model, WCF, will deserialize the original object, which has now got a new name because it's not really being used by the business tier. And that old object with a new name, once you have it deserialized, the service code can say, okay, I need to make a copy of this into the new business object type, and then call down to the business object accordingly. You might also create a shared piece of functionality for the common operations, and then that way you just have to map to the new object, pass it into that shared functionality. So for example, if it's operation 1 receiving the link item, then service, the original endpoint service, will call down to this shared implementation of operation 1 after having mapped to the link item from the old V1 link item. You can also avoid the double mapping if you're concerned about the overhead of that, which I don't know that I'd be concerned about the overhead there if you're trying to migrate people to a new endpoint, because then I guess they get what they've asked for because they haven't migrated yet, right? But if you do need to sort of optimize this a little bit more, then you could go with the iXML serializable approach, which I talked about in my last webcast. Fuzzy on versioning. Is there a way to find out when there's no usage of version 1 so that all clients can use version 2? Well, that's really you managing your callers, right, and managing access. So you could log the frequency of access to the version 1 endpoint using either performance counters, or if you want to be more explicit, then you could obviously create your own logging facility for that. I would say I just use performance counters and take a look at the trends and see if the usage has gone down. And then at some point, maybe you start throwing exceptions saying this is obsolete, and that will be a SOAP fault that the old clients get eventually. If you're using WCF, is there any reason to use ASMX or remoting? I would say no, absolutely not. I suppose one thing I might consider, but I really would avoid this, is that remoting does allow you to do marshalling within the same app, within the same process across app domain. And you can do that with WCF, but it will be a little bit more challenging. A little bit more overhead because you're going to have to serialize, whereas with remoting you could do marshal by ref. But I still don't think that's really a reason to stick with remoting, because we really want a baseline on a single object model, and WCF allows us to do remoting enterprise services and ASMX things. So I would just stick with that. I talked about operation contract and data contract versioning. Well, actually, service contract and data contract versioning. Message contract versioning is going to be similar to data contract versioning, because you make that change and now you're going to change the service contract. So absolutely right. Now, because normally message contracts inherit the same namespace as the service contract, then you just have to make sure when you change a message contract, you change the service contract and couple those. And then that way you don't have to do any explicit versioning on the message contract. Okay, is there, I'm just going through the questions. What effect do I see on the new dynamic languages on services in general? Well, I mean, I think if you're talking about VB.NET as a dynamic language and C# 3.5, or you're talking about Ruby on Rails and other types of things, I'm not really sure what you mean there. So I'm going to let you either email me that or rephrase. The difference between strict and non-strict versioning is really just in your internal approach to whether or not you want to track every change that's ever made after you've gone live with version 1. If you're in an agile environment and you need to sort of make some tweaks and you don't want the overhead on the release because it's a monthly release, then you might not want to do strict versioning except for when something significant changes as part of a major release. And that's acceptable. Again, it's all about the company. I've worked with some companies that absolutely require everything to go through configuration management, formal change process, and in that case you probably want to just get your strict versioning together. I think that's it for the question, Sarah.
All right, sounds good. And to view a replay of today's live event or to register for upcoming webcasts, simply go to microsoft.com/webcast, and the replay will be available within the next 24 to 48 hours. So thanks again, Michelle, for the great webcast. Thanks to everyone for joining in, and have a great afternoon.